make a start. So good afternoon. Thanks for tuning into this session. So my name is Jordan Donnelly. I'm a IT Applications Principal at KBR. And I'm excited today to dive into this topic on scaling smart, designing high-performance Appian applications. So let me just start with a quick question just to get to know our audience. How many of you have applications in production already? Okay, so most people. Keep your hand up if you can answer confidently this question. If the number of users and the volume of processes doubled in your applications today, would your application be able to handle it? Show of hands? Okay, good. What about triple? Okay, interesting. Quadruple? Okay, that helps. So we're going to dive a little bit into more about giving confident answers to those types of questions. But let me just set the scene for a moment. So a while ago, a number of years back on my Appian journey, I was brought onto a project that was already mid-flight, had been in development for a number of months already. So all the architecture was already set up, the key design patterns, the core design patterns were already well established. And so in order to keep with the delivery timelines that we had set, we kind of kept within those parameters that were already there. And so go live came around, and it was great. The business adopted the tool really well. The performance, the feedback was really positive. The business was really happy. It's all going great. And then before long, we had some warning signs that started to show. Just simple user interactions in the application started to take a little bit longer than they should do. We had interfaces that were slower at loading than they should be. Background processes started to back up. And so before long, a bit of noise was starting to be generated amongst the user base talking about performance, and it led to leadership coming and asking, what's going on? What do we need to do to get rid of these performance? Do we just need to add more resources? Do we need to purchase more Appian resources and scale up that way? And so the answer initially we gave was yes, let's do it. We got more firepower, more CPU, more memory, and it was great for a while until those warning signs started to come back again. And so this time the business were asking, what's it going to take to get this working? They said that they were planning on doubling the number of users, doubling the volume of processes and records that were coming through the application. So the real question that we needed to ask was not just what will it take to get rid of the performance issues, but what would it take to double our application's scalability and process throughput. And that's the context from where I kind of had to wrestle with some of these performance questions. And this is the backdrop from where I'm sharing the principles that I've learned through that. Because performance isn't just a platform problem. Often it's a design problem, and you and I as developers, as administrators, as architects do have a significant influence over the scalability of our applications. And so we're going to look at the journey that we're going to go through. So I think one of my slides has been removed. But yeah, we're going to the agenda that we're going to walk through. We're going to look through 4 parts. We're going to look at diagnosing Appian, diagnosing performance bottlenecks. We're going to look at spotting performance anti-patterns and what we can do about it. We're going to look at how you can get more out of your platform resources, the resources that you already have before we kind of scale and purchase more Appian resources. And finally, we're going to look at turning all of those insights into a roadmap that your stakeholders and customers can get behind as we address it. So we're going to start, first of all, with diagnosis. I'm not aiming to cover every single monitoring tool that there is. I do just want to give you some tools, put some tools in your hand to isolate where the time is going, understand where the time might be going if you are seeing some performance issues. Because when someone says that that the application feels slow, it could be a number of reasons. And the key thing is that you and I and our teams, we don't have to guess. We don't have to go off gut feeling. We can follow the evidence and understand exactly what is going on. So when you look at Appian end-to-end, and this is just a typical kind of setup, you may have already customized your environments according to your needs. But when you look at Appian end-to-end, a typical user interaction will go through a number of layers. It'll pass through the client layer, which will be rendering the UI. It'll pass through various network layers that might be trying to get requests to Appian safely, enforcing certain security boundaries. You'll have your application server, which will actually handle those user requests and do other background activities. You'll have your engines are a part of that as well as your data layers. And on top of that as well, you'll also have your own external systems that you're using. Maybe you've got various number of integration partners and third parties that are using, connecting to your application as well. So there's the agenda slide. So I don't know what's happened here. I think someone might have changed the order of the slides. Okay, I'm just going to go with it. So, forgive me, someone's changed the order of the slides there. So, but yeah, so as you become more familiar with your platform architecture, we realize that slow performance isn't just is a question of which platform component specifically is under that pressure, and how can we look at that. And so, there we go. So where would we start? So first of all, if you've been in Appian any number of years or whatever your Appian experience is, there will be some tools that you are familiar with and that we'll all know and are quite visible to us as developers. So we've got the monitoring dashboard, which contains all that process instance data, your process memory footprint, your query performance, record performance as well. You also have your performance view on some of your integrations, on some of your objects like integrations, your expressions, your interfaces have that performance view where you can break it down and go into where the evaluation time is coming. And you'll also have health check. If you run it frequently enough in your production environments, that also gives you some really useful insights. So if any of these flag any objects, slow interfaces, high-risk findings on your health check, that is an early indicator that your application might not be ready to scale to the next level. Now, 80% of the time, these tools will be enough and serve your purposes. But when you're trying to answer a question like, what is the scalability limit of our application? Or maybe you're trying to diagnose a performance issue where the root cause isn't as obvious, there are two other tools that I want to highlight and put into your hands. And so first of all is HAR files, a HTTP archive browser network capture. You can create these from your browser developer tools. It essentially works as a recording. You'll hit record. You'll click through the various interactions that you want to diagnose, and it builds up a file for you. So you can think of a HAR file as being a timeline of everything that the browser says to the server and everything that the server says back to the browser. And each line in a HAR file represents one request, whether it's loading an interface, whether it's calling an integration, whether it's downloading a document, or refreshing a grid, a records-backed grid. All of that gets a timing breakdown that you can kind of understand where all the time is going to. It'll break down your kind of DNS lookup or your TLS handshake. How long did it take to download that specific document? So a HAR file is really useful for answering that question quickly. Where is the time going? Is it being spent on what Appian is doing, or is it outside of Appian? Is the delay before the server responds, or is it during the server processing? Is it one request that's slow, or is it a lot of small requests that are piling up and building that? So yeah, again, you're going to be able to separate and identify how much is being spent on network and VPN latency, how much is going towards the server response latency, and how much is kind of on that client side. And yeah, a HAR file really enables you to look into that and answer that question quickly. Are we waiting on Appian, or are we waiting on something outside of Appian? And if you are waiting on something outside of Appian, then that's where you'll have to engage your appropriate teams, your customers or your business's network teams, for example, to help with that side of things. But if it is on the Appian side that you are seeing the slowness, then another tool I want to highlight for you is the system logs, often underused by us as a development community. Now, health check is a powerful tool, and health check does analyze a number of performance logs, But you have to remember that health check is just a summary of those logs. It might not reflect the specific timings and patterns and usage patterns of what you're seeing and what you're wanting to investigate. It won't, for example, help you answer the question of what was happening at that exact time that a user reported an issue. And so that's where system logs will come in, because Appian produces a wide catalog of performance logs. You've got it broken down per smart service, your smart service performance logs, your integration performance logs, record performance logs. It's all there for us generally in a CSV format for further analysis for us. To show you an example of the value that system logs provide, here is how it kind of worked out in one of my projects. So we had a users reporting that system background processing was taking way longer than what they were expecting. At that moment, health check wasn't really flagging anything. It showed a few medium risk findings, but again, they were for process models that weren't really to do with the functionality that was in question. And likewise, as we looked at the performance views, there was nothing obvious standing out about the findings that were there. And so I turned to the system logs and began to go through each of them just to break down each component of that Appian architecture that we looked at earlier, trying to find what's going on and how is it working. And I found two really useful insights. The first one was that as I looked at the engine performance logs, I could see they were just constantly overloaded. And to be more specific in that, the idle time on the engines was showing in that 20 to 30% range, essentially saying that the engines are just always overloaded and barely have any breathing room. The second insight that we gained was that we could see for that same time period that the user was reporting it, we could find the top, as I was looking at the process performance logs, I could see the top 5 process models that were consuming those resources at the time. And that was so helpful, because now we're not just guessing it anymore. We have a clear platform component that's under pressure. And we have some Appian design objects that are contributing to that component's capacity constraint. And that's the whole goal of this diagnosis point. We want to take a symptom, like it feels slow. We want to trace it to a component in your Appian architecture, and then we want to be able to identify the objects and the design objects that are consuming those resources. Because once we found that component that's under pressure and the objects that are responsible for it, it enables us to ask the next question. Is this a design problem that we can fix? Are there performance anti-patterns within those design objects? Now, the goal here, just as a side point, the goal here isn't to kind of shame people on your team for building these things. I remember when I was first looking into some of this stuff, and I came across an interface that was really poorly designed, so I ran to the version history thinking, who was responsible for this, only to find it was me, about 18 months earlier. So the goal is never to shame anyone, but it is an opportunity to adopt your code review best practices, your coding standards within your teams, and it's an opportunity for us all to grow as we improve our knowledge on this subject. Now, Appian documentation does speak to a number of performance anti-patterns, so again, I'm not going to try and cover everything. I do want to just give you highlight 2 of the most problematic design patterns that I've seen in a number of production applications, ones that have the biggest potential to kind of bring an application to its knees. And so the first one I want to talk about is poorly designed extract, transform, and load operations, or ETL for short. So remember that your application server isn't just handling the immediate requests that your users are interacting with. It's also seeing to background processes. It's running scheduled processes, executing those timed actions. It's sending out notifications and things like that. And when that background demand exceeds the capacity, that's when the work can start to back up and makes everything feel a little bit slower. So if your ETL processes are running during the day, they can almost be competing with the same resources that your users are trying to use. So here are some design principles that I've found most effective when refactoring some of your ETL processes. First of all, you're going to want to try and reduce, as best as you can, reduce operations. High operation counts indicate kind of process-heavy designs, whereas executions that are taking longer to complete indicate really heavy operations. And when you get both of those coming together, and high number of execution counts and heavy operations, typically that's when we're going to see the worst performance start to arise. Row by row ETL operations, where you'll take a list of records and start iterating through in a loop, transforming the data, is the biggest culprit for that kind of stuff. And because at scale, as you increase your scalability, as you increase the number of processes that are going through that, it's just going to scale the amount of capacity that's taken away from the engines. You're going to want to reduce the operations where you can. For example, a single database, a stored procedure, can handle thousands, the transformation of thousands of rows of data at the same time, instead of having Appian loop through thousands of operations in one go. The database is way better suited to handle those set-based operations. That means that then Appian can become more of a coordinator of work rather than doing all of the heavy lifting itself. So again, reduce operations where you can. Following that, batch processing. Sometimes those row-by-row patterns are unavoidable. Maybe you've got an integration that's in the middle of that transformation pattern. In that case, you're going to want to try and introduce as much batching as you can, because those breaking it down into smaller batches provides those natural breakpoints where you can load balance. Using, for example, the start process, Smart Service allows you to load balance that work in smaller batches across the resources that you do have. The third one is about control processing. Now this will look different depending on your context. Just to give you an idea of the kind of things that I'm talking about, so you want to try and put as many controls in place to enable your teams and the system itself to kind of handle and distribute this heavy lifting automatically. So we had a external system that would dump sometimes thousands of rows. It was quite unpredictable in how many rows. There was not really too much pattern. It all depended on the season that we were in because of the industry. And when thousands of rows, for example, would drop into our database for some ETL processing throughout the day, it did often cripple our performance. So what we did is, working with our business to understand what really mattered in their data, we introduced a delayed processing, where certain records, depending on their criteria, we knew that we could delay till last and prioritize more important records. So we would stick, for example, conditional delays and performance processing times. We also exposed that full list to our users, so that users, when they were kind of wondering what's happening to my record, why has it not been processed yet, they could access the full queue of records that were there to waiting to be processed, as well as all the conditional delays and times that we put there. So again, it just cut out all of the noise of users saying, what's happening to my record, where is it up to? Other things to mention is we also included things like toggle switches for our various services. We had lots of different ETL processes, all with different purposes running throughout the day. We were able to toggle, turn on and off certain ones depending on the time of day it was, or different things like that. And it means in your lower environments, you can just switch those off altogether and be preserving that resource in there. Another one, again, this is just ideas to help you think about ways, how can you control your ETL processing, is that we exposed an admin function where all of our ETL processes, admins have the ability to schedule each process for different parts of the day. So during high periods, high volumes, they were maybe able to schedule them at different times, and during low periods, they could maybe avoid the busiest part of the day altogether and just push them to either side of the business day. So again, just want to try and trigger some thoughts in your applications. How can you put more operational controls in your ETL processing? The second anti-pattern is with what I would call casual data management. So memory pressure is often a data retention problem. And the question that I would always ask you if you are facing memory problems is, can you adopt a more aggressive data management strategy? For your completed process instances, you'd all be familiar with the setting on the data management thing where you can set the days after completion when you want it to delete. Typically, as you create a new process model, many of us would kind of go for the, 3 or 4 days deletion, which is fine. But if for process models where you're going to have high volume and scale, that can start to build up and take up a large memory footprint. Going all the way to a 0-day or zero archive deletion policy really does have a big impact on your memory footprint. And one of the ways that you can do that is simply just by setting up your own log tables in an external resource, such as a database that can scale up on that memory side. That way, at the end of each process instance, you can just have a simple write where you capture important audit history, status changes, API responses, save that in your database, and then you can delete your process instance straight away. And you will be surprised how often that has a massive impact on reducing your memory footprint. Further to that, for your process instances that are active, often for those design patterns where you have a process wrapper that kind of connects all of the various user tasks, the effect of that is often that our users, if they're not addressing their tasks straight away, it's leaving active tasks open for a number of days, if not weeks. So again, as you scale up and the volume of those increases, it's going to hold a bigger memory footprint. Another way to address that, it's quite an aggressive change again, but it will reduce your memory footprint, is moving away from that user input process kind of driven workflow over to a data-driven workflow, where you have a number of task types in your database that have an associated process model, and that process instance for each task only is activated when the user wants to interact with it to complete it in an interface through like a start process link, something like that. So it means you could have thousands of active tasks, but no active process instances, because it's all controlled in the database, and that process instance is only activated when the user is ready to complete it. It's a very aggressive change. It will change the way your users interact with tasks. For example, you'll have to think about how to replace the out-of-the-box functionality of exceptions and escalations, but it is going to have a massive impact if scaling up on your tasks is what you need to do. So something to consider there. So yeah, again, if you're facing memory strain, ask yourself, how can we adopt a more aggressive data management strategy? Okay, so at this point, we've covered quite a lot already, but at this point, just to recap where we're up to now, if you're following this framework, we'll have taken a symptom, like it feels slow. We would have traced that to an Appian platform component that's under pressure. We'll have found the associated design objects that are consuming that resource. We'll have also looked at the design objects and said, is there any performance anti-patterns that we can refactor? And that brings us to this point, that if we've done all of that and we're still seeing some capacity limits, we're going to look at the components that we have and ask the question, how can we get more from the resources that we already have? Because you might be looking at a genuine resource constraint. And this is something that you can do before you make that big purchase of just getting more of everything. Again, we're going to look at how you can get more of what you've already got. A helpful way to think about scaling is in two buckets. You've got horizontal scaling, increasing the amount of concurrency in your applications, increasing the execution capacity at any given moment, more processing swim lanes, if you will, so that the work can spread out. And then there's also vertical scaling, more firepower, more CPU, more memory, scaling vertically. A few practical guidelines to kind of help you in that decision making. Again, this isn't an exhaustive list. I just wanted to give you ways to think about these problems that you'll be seeing. So here's a few practical guidelines on that when your CPU is constantly in that danger threshold or approaching your CPU limit, it's really hard for anything else to improve until there's more headroom. And that's going to be a case where, if you've done everything you can from a design perspective, then scaling vertically might be your option. Likewise, for your memory, if you've taken an aggressive memory strategy and you're still seeing those memory constraints, again, scaling vertically might be your best option there. However, if process throughput is the constraint that you're seeing, just not able to process concurrently as much as you can, but you do have the CPU headroom and the memory headroom, there's an opportunity to scale horizontally. If the execution is just constantly busy all the time, adding more execution capacity will help in your situation. And I'll come to an example of that in a moment. Likewise, another example is if your number of users is scaling up, and so your interfaces start to slow down, your app server is struggling to handle the different requests, then adding more application servers is another form of horizontal scaling that is going to relieve some of that pressure and some of that stress on there. If you are looking at where your CPU and your memory are fine and your execution engines don't appear to be overloaded, but stuff is still backing up, it's most likely going to be due to a downstream resource, such as a database, that is causing those bottlenecks. Admittedly, you are going to have to perform a similar exercise on that external resource, look at diagnosing it, whether you need to scale up, whether it's query performance, indexes that are missing, or whether you do need to add more resources to that. So it could either, when it's an external resource, it could be either one, but it's going to be a bottleneck, because in that situation, even if you were to change the other components, add in more CPU, add in more memory, if the database is still the bottleneck, even though you've got all this extra firepower, you're not going to see any additional improvement to your performance. So it's worth noting that that's why it's the title of this session is Scaling Smart. We want the evidence to tell us what to scale, rather than just defaulting to those big platform upgrades. So yeah, just to give you a real-life example of what it looked like in my project. So going back to that diagnosis period, when I was wrestling with these and I was trying to answer that question of what would it take to double our processing capacity, I actually went through every of the core components, went through the logs and mined the data. I had it all set up in different usage patterns that I knew our users kind of interacted with the application. And so for every component, whether it is heap memory or engine idle time or engine other time, I had it all mapped out in different usage patterns, and also the variance of it across, so I could really get an insight into what we were seeing. And as I came to that, I saw just two insights that helped make the decision as we were speaking about scaling horizontally or vertically. Some periods showed that it was that the executions were backing up because of a downstream resource. In our case, it was the database. Other resource patterns, usage patterns showed that there was sustained strain on the execution engines, and things were just backing up, causing a backlog of operations to get through. And so it told us that we weren't dealing with a single bottleneck, but scaling everything wouldn't have had an impact as well. So our response to that data was we scaled up the database. It was an easy one for us, because often your database doesn't have to be provisioned with the same CPU and memory that an application server would, for example. It's often much cheaper to scale something like that up. So that was an easy one for us. Secondly, because we had the CPU headroom and the memory, we added 2 extra pairs of execution and analytics engines to give more throughput capacity to that. Again, at no extra cost to us there. That's just something you could work with your Appian support teams and get that resolved. So again, we didn't scale everything. We scaled those components that were under pressure according to the parameters and according to what the data was telling us. And it's our job as designers, architects, administrators to scale smart in that regard. Okay, so just to bring this to a bit of a close, just wanted to finish with a few implementation tips, because maybe you're in the middle of some performance challenges, wondering what's it going to take to get out of here. I remember feeling the pressure of that, the stress of that, and having a roadmap to work alongside really does help plan your way into success. So again, recapping what we've learned so far. So if you're following this framework and you take it back to your own performance challenges or answer some of those questions, you'll have taken a symptom, like it feels slow. We'll have traced that to some components that are under pressure in our application architecture. We'll have identified the design objects that are contributing and consuming those resources. Of those objects, we'll then have looked to see, are there any anti-patterns that we can refactor? And finally, for the resources that we do have, we've looked to see, can we get any more? Can we scale horizontally before scaling vertically? And that leads us to where we are now. Now, this performance work that you've identified, that refactoring, is going to have to be prioritized against other work that you have agreed to with your customers, new features, things like that. Bringing your product owners and stakeholders into the conversation as early as possible, being as transparent with where you're at, is really going to help with some of these conversations. One way we really benefited in these conversations was changing it from, instead of talking about we need to refactor interface X and process model Y, speaking about it in terms of the business value. So instead of saying we need to refactor interface X, you could say we need to speed up the onboarding workflow, reduce the wait time that users are seeing in this way. Again, just helps with that whole prioritization that we're going to see with your product owners. Performance work won't be a one-off task. Once you kind of do some of this work, it's not just job done. You need to constantly be reviewing this kind of stuff. Could you, for example, put in a performance review session after every time your health check comes out? Maybe just a 15-minute, 20-minute meeting where you just review, has there been any new high-risk findings, any medium-risk findings? Keep in touch, be aware of what the data is telling you. Catch those things early rather than wait until your users complain about it. You're going to want to revisit your baseline metrics, seeing what did we start with, comparing it to what you're seeing now, and that'll give you the answer is, are we making the changes that are benefiting our users? Because if there's not, maybe we're doing something wrong in our approach. But if you are seeing evidence of your improvement, make sure you communicate your success to your business. Tell the story of your success. Tell them how much time you're saving users instead of waiting on this interface. Tell them how quicker your onboarding process is becoming. It builds trust, because when you ask for performance time, kind of budget for performance improvements, you've built that trust with them, and it's likely to get it in the future. One unexpected lesson I learned was you can make this process fun. Again, like I said, the pressure of it and the anxiety of having these performance challenges and feeling like it's all your fault can get to you. So it is important to make this fun. I mean, it's fun to me anyway. I don't know if it's fun to anyone else, but we had some metrics that were on there that we were really trying to bring down, like very aggressively reduce. And so every time we'd release some performance improvements in a sprint, we'd be back into work on Monday, coming into work thinking, gosh, how much have we brought it down by? It became a competition between us who could bring out the best performance in the application. And so it's just a shared sense of achievement and commitment and contribution from your teams that will drive this through. And again, just to take away from the high pressure that can often come in situations like this. So just a few pointers there on implementing this kind of stuff. Partner with your business, create space to improve, track the progress, and celebrate your wins. So just to, again, summarize what we've covered. We've covered a lot there in a short space of time. We're going to start by diagnosing, taking a symptom, like it feels slow, mapping that to the component that's under pressure, finding the resource, the design objects that are consuming that amount of resource. Of those objects that you've identified as being problematic or contributing to the resource constraint, is there any opportunity to refactor those? Are there any design anti-patterns, performance anti-patterns in there? We've looked at how to get more out of your resources that you already have. Is there opportunity that we can scale horizontally before scaling vertically? And finally, some implementation tips to build a roadmap that will help you succeed with your business and your product owners. And if we can put these practices in, build these practices into our everyday development, I'm sure this community is going to continue to build applications that not only meet your business's scalability goals, but are world-class and stand the test of time. So I have just 2 quick action points for you of what I'd challenge you to do after this session. So for those of you who did raise your hand for your production applications, pick one application that you own and ask yourself, what is your application scalability limit? Is it double the users we currently have? Is it triple, quadruple? Could your app handle that load if it dropped tomorrow? Second one is just to continue your learning. Take what lessons you're learning here at Appian back to your teams and teach it to them. There's also 2 more performance sessions coming up this afternoon. We have Stephanie Kamga and David Pullen, who David Pullen is architecture, head of architecture at Appian. So again, 2 more opportunities to learn more about performance and keep refining our skill set. And also to stay up to date with Appian's performance tools. Autoscale is available as well. It was one I could have mentioned in the design pattern stage. So I keep up to date with things like that. Again, more opportunities to improve your application's performance. So with that said, I think we've got a few minutes left for questions, so happy to take questions if required. Yeah?
You said that you would be scaling horizontally and vertically. I understand vertically with What would horizontally be looking like?
So horizontally is adding more throughput capacity to what you already had. So in my case, we had, I think out of the box for standard kind of instances of your Appian environment, I think it's 3 execution and analytics pairs. Because we had the extra headroom and the extra of CPU and memory, we added 2 more sets of execution and analytics pairs. So added just that extra room for us to be able to process throughput. So that's one example. Another one that I mentioned was if you've got a lot of users coming on, you can work with Appian support to add more application servers that will distribute that user load as well. So they're the kind of thing that what horizontally scaling looks like. If you want, afterwards I can send you some documentation that's really helpful and explains this more in depth than the time that we have in this session to go into. But yeah,
that'd be great. Thanks.
Thank you. Yeah.
So now that you've gone through this process, you have a way to measure performance at any given point. Do you see, or I guess, how do you measure performance after you do an Appian upgrade where there's an expected gain in something like the data fabric performance? Do you actually celebrate those things in the same way you do a release?
Absolutely, yeah. Because even a vertical scale does represent an investment into performance, and so if you see in the response times halve, for example, for certain interfaces, definitely worth celebrating the success in that regard. Is that the kind of thing you're asking, or?
Generally, yeah. Was there any specific point in time when you realized, oh, we did this upgrade and suddenly things are massively improved? And if so, what action did you have to take to fully realize those? So, for example, Appian has changed some of their default query behaviors, and as a result, versioned query record type, as an example. But there are other cases with the auto scale that they have as well, where they've improved performance in specific things. But if you're not measuring them, you don't know you necessarily need to change to keep up with how Appian's changing.
Yeah, so the 2 anti-patterns that I shared for us, which was the data, casual data management strategy and the ETL. So I mean, it's going to be different for every person's, but ours was very ETL heavy, just the number of operations that we were doing. So as we refactored those, released it the following sprint, the difference was so dramatic that it was like worth celebrating. And likewise, as we transitioned to that more aggressive data management strategy, it was one of those, especially on the ETL side, but we literally saw, because Appian support also have some kind of snapshot metrics where you can track it, the response times of some of those things dramatically dropped, and it was so clear that the change we'd done. I should say that on ours, we negotiated with our product owners to kind of have 2 dedicated hardening sprints, which we were quite lucky to get, really. And that was why we were able to kind of front load so much of our performance in the first 2 sprints, so that when we'd released certain improvements, afterwards, after that sprint had finished, the metrics were quite dramatic. Often, if you don't get a full hardening sprint, you probably phase your performance changes in, and it'll be more of a subtle improvement in performance rather than all at once to celebrate. But yeah, I mean, in regards to your version and things like that, nothing's jumping out, apart from putting more controls in place of how we actually handled and smoothed out the curve. But we didn't particularly do anything with versioning. So if you've done anything like that, I'd love to catch up with you afterwards and hear what you've done. So yeah, thank you. I think we've got time for one more.
So I feel like at some point you are going to need to increase your resources. Are there any, telltale signs or evidence we could take to our infrastructure department to say, it's not me, it's you, and ask for those resources?
Yeah. So I mean, from your infrastructure side, your half files will reveal anything that's immediately obvious about stuff that's outside of Appian. Things that are internal, again, it just comes down to those metrics. If you've done all of your design things and you're still seeing that there's going to be CPU that's just, you're not able to bring it down, and you've made all your aggressive data management changes and you're still at your memory resource limit, it's inevitable that you are. And it might be that you get to a certain point having a really performant application, but the size of your Appian instance just isn't big enough to take it where your business needs to go. So there is a genuine business case for scaling vertically. The point I was making was it's more often it can be the default change that we make, and the improvement is marginal and only temporary. But yeah, there's definitely a time when you say, no, we need more CPU, we need more memory, otherwise we're not going to meet our business's scalability goals. So yeah. And it's also worth mentioning, and the stuff that I haven't touched on is improving our intake process for applications. That when you get in a new application, it's important to improve the processes that go into starting an application. Things like understanding your business's scalability goals right from the start, doing your performance testing to a good level, which is one of the sessions that David Pullen is doing later on. Getting all those things, improving that intake process before you go live is going to improve your ability to give confident answers on that as well. So yeah, it's a relevant point that we didn't get to cover in this, but thank you. Any other questions? Yeah.
Does Appian Cloud has anything specific, any tools which can help? Like,
Yeah.
I mean, I don't know, this infra that you were showing, was it specific to cloud or more of traditional implementation?
So being honest, I haven't actually worked on a self-managed, so my experience is only from the cloud platform based. And Appian support out of the box do come with some monitoring tools. So the tools that we discussed earlier, your monitoring views, your performance views, your health check, they're all out of the box with whether you're self-managed or cloud. The cloud instances that I've worked on do have Appian support. Give you in their support portal, you have your metrics that are all there that are quite close to real time. It does expose your response times across the application. It monitors your CPU for up to a certain period. I think it's 90 days. Likewise, you've got your heap memory, disk memory, RAM. So those things do come with Appian Cloud for monitoring it. But when you want to track more different usage patterns, or you want to go further back in time, or you want to go deeper into the analysis, then things like your system logs will be there as well. So.
Okay. And do you think there should be like auto scaling in cloud? Like,
oh yes, of course. Yeah, there's auto scaling as well, which is there to make the most of it if you have that tier of Appian features. So yeah, where you can kind of select which process models you want to allow this elastic capacity to kind of enable that on. So yeah, auto scale is also a great option with Appian Cloud. Yeah.
Okay. Yeah. Thank you.
We've got a minute and a half left, if anyone has any.
So you mentioned you were using some logs to kind of help you diagnose your performance. Did you do like a manual kind of search for those logs and then it just stood out to you, or did you like pump that into like a Splunk or something to help mine that time series and figure out where your hotspot was?
Yeah, so admittedly, I did do a lot of the work manually, which I probably wouldn't recommend now. I'd probably look at and put in something that's much more efficient, like a Splunk, and put it now. But I did go through manually, and the reason was because we was trying to answer that question of what are our application scalability limit. So I did want to just get to grips with each individual component resource and map it out. Definitely not an efficient way, so I would agree there. In fact, if anyone does have an effective way that they've seen it done, I'd be interested to connect afterwards. So the method there, I'd totally be open to changing and adapting, but the insights that you do gain from that level, where it's more automated or whether it's manual, the insights are super valuable. So, yeah.
Cool. Thanks.
I know we're out of time, but yeah, I would love to talk to anyone in the room afterwards if you have any experience with, say, integrating those logs with Datadog or tools like that, because it's kind of an active pain point for us that we're trying to figure out a more effective way to, analyze these things outside of, say, the health check, because it's not quite providing what we really need. So, thanks.
Yeah, let's all connect on that point. Yeah, that'll be good. But yeah, I think we're at time there. Thank you so much for coming. I hope it's been helpful.